cold temperatures in Kansas and Oklahoma today, but North Texas is right on the dividing line. Thanks for joining the Meteorology Lab channel. I'm Tim Vasquez, and for the next 20 minutes we'll be taking a look at the weather around the country. We had pretty warm conditions where we're at today, pretty much right at 80. And you saw some cirrus there just a minute ago. But we've got Venus out, and a little bit of astronomy news. Venus is at its highest point in the evening sky, which means it's the best time to see Venus. A lot of the times Venus is directly in front of the sun, or it's a morning star on the other side. But this is pretty much the optimal time, especially if you're an evening person like I am. Temperature anomaly maps looking kind of like a pretty good contrast of air masses. You can see a lot of that warm air focused anywhere from South Texas out to Atlanta and the Carolinas. It's pretty much cleared out of Quebec and Ontario. You can see the cold air is kind of just blown right through that area. And some of the cold air is shifted down into the southern plains, and you see a very strong boundary. Now the frontal system out in the west U.S., that has resolved a little bit better compared to the past few days. Got bitterly cold temperatures below normal in the northern Great Basin area, the Washington deserts, and above normal in the high desert of Gallup and Deming, Silver City. And you notice in Baja California, San Diego, and Los Angeles below normal all the way down here. So we're probably seeing the cold front slipping south, kind of like that. And one thing that you notice here, see the Baja California? You can see blue up in the mountain areas and red all around it. That's indicative of a very steep lapse rate. So probably very unstable conditions across this area here. All right, let me check over on the chat real quick and just make sure audio is up. And I see we got Mark on here, and Alexi, and Kevin, and Michael, Jeff, and there's Ron there underneath the cutoff low there in Southern California. Kevin, yeah, the front is right in the area. I was hoping it would be a little bit closer because I want to get some time lapse of a roll cloud or something moving through, but no dice today. Tom J. in Las Cruces. Let me add that to my notes real quick. I'm trying to keep track of where everybody is. I'm thinking maybe tomorrow or on Sunday, maybe I'll kind of like bounce around between different people's locations and look at you guys' weather on the soundings and surface charts. Okay. And the skinny in Medford, Oregon. I actually applied for a weather service position out there back in 2001 or 2002, just on a whim. So I could have very well ended up out there. I can't even imagine that. Okay, great. Chat is going, and let's move on here. 500 millibar chart showing the northwest flow is pretty much broken down. You remember several days ago we had a large ridge and that descended to a large trough out in the eastern U.S., and that advected a lot of cold air southward. So we've kind of broken down that pattern and really opened up the Pacific. So you see where these lines are very close together out in the Pacific? That's where we have very fast flow, very powerful river of air in the mid and upper levels. Focused mostly on the British Columbia coast and Washington, but of course, Los Angeles, they've got a cutoff low down there. Southern California, San Francisco, cutoff low. You can see Vandenberg Air Force Base here west of Los Angeles. They're showing south winds, which tells us that the cutoff low is off to the west. If the cutoff low is east of there, we would have a north wind at Vandenberg, and that would help fill in that counterclockwise spin there to the air mass. So that's kind of what's happening down there. And out ahead of that, southern stream coming up from Arizona and Colorado. And you can see a bit of a ridge right here from Oklahoma to Colorado. And the main trough is still way off the west coast. In between, not really much going on in this area. So that's the reason we're not seeing a huge development of precipitation as we might have on some events with the cutoff low out to the west. So pretty quiet for now. High temperatures, they looked like this today. You can see that huge difference, 82 at College Station, 81 at Austin, contrasting with 49 there at DFW and 29 at Oklahoma City. And that's a little under what was forecast a few days ago. So basically the cold front is kind of like that. And then we pick it up out in the western U.S. out here. Lots of 50s and 40s. I think that 75 has been bad. Is a bad value. I've been seeing that for the past few days. So probably the front kind of like that. Very cold up there in Oregon. Teens and 20s. So what does our sounding look like? Well, before we do that, we might want to look at the surface data. Let me bring that up real quick. And I think I've got 6 p.m. data loaded in here. Let me fix that. Okay, so here comes the current data. We'll wait for that to process. And I think we are set here. So North Texas and Oklahoma right now showing pretty good north wind. Front is located well to the south in this area, basically from Tyler, Texas. Looks like it just came through Palestine here with a west wind and moved through Austin also. So it's on its way south. And one thing I wanted to show you a little bit was model verification, how the models have been handling this front over the past few days. Before I do that, let me just show you the one more look at the surface data. Looking at kind of like that. Front a little bit north of Fredericksburg, but south of Junction, south of Ozona, and down to Sanderson. So kind of like that. Okay, so you got that. All right, let's check out the model verification. I'll use my slideshow viewer for this. What you're looking at right now is temperatures. So where blue is, that's cold surface temperatures. Red is warm temperatures. And this is forecast data. Everything you're going to see here is valid for 6 p.m. this evening. And you can see I have different numbers printed on here. These big ones, these are the observed values. And the small ones are model forecast temperatures. In this case, we're looking at the GFS. And this GFS data is 3 days old. So 3-day-old GFS data from Tuesday. And you can see I've plotted the actual front here in blue. So you've seen where that is on the surface chart. And the green is where the model indicated front seems to be. That's kind of drawn in by hand there. So what does this show us? 3 days ago, the GFS had the front. It was thinking that it was going to be lying way up here near Ardmore, near Wichita Falls and Lubbock, very far north. And you can see it was forecasting 64 for Dallas. We actually had 45. Also in Oklahoma City, forecasted 37. We actually had 29. So conditions are a lot colder than the model had forecast, and the front is a lot further south than it had forecast. So how do you think the Canadian model did? Maybe some of you have followed the Canadian model here on the webcast. We know that it's been pretty interesting because it has gotten a lot of these situations pretty accurate. Let me bring that up. Let me hang on a second. Okay, we'll put that back. Let's check out what the Canadian model had forecast 3 days ago. Looks a little bit better. And especially you look at southern Arkansas here on the warm front area here. The warm advection wing, I guess you could call it. And it had got the temperatures at Little Rock pretty close. Forecast 42 is actually 39. Let's check out the GFS. Go back to that. The GFS had been forecasting 60, and it had the warm front a lot further north. So that Canadian model is actually doing quite well. So 1 day ago, here's what the GFS had. It was a little bit closer there. Not quite to the actual location, but probably within about 75 miles. Temperatures are still a little bit off here. And let's see what this one is here. This is this morning's GFS. So it got even a little bit closer, but not quite there. Maybe about 30 miles position error here. I did that again. Let me switch back here. Okay, and we'll check out some of the other models. This is the NAM forecast from this morning. So this is basically a 12-hour forecast. NAM pretty much nailed this. The NAM is basically the WRF run at INSEP, which is the modeling branch of NOAA. So it got that front pretty well dead on. Temperatures, they look pretty good. Again, slightly warmer than forecast, but models temperatures look pretty close. Little Rock is a little bit in error. Other than that, not too bad. High resolution rapid refresh. Well, the latest I could get was, or the oldest I could get was 6 hours ago. But pretty similar performance for that 6-hour run to the NAM. Then the other model we can look at here, this is the 3-kilometer version of the NAM. This is from this morning. 12-hour forecast. Even better. Man, that's pretty much precise. And I may not have perfect positioning here on my surface front, so this may have nailed it almost 99%. I'm pretty impressed here. 3-kilometer NAM there. So for a short-term model, that's probably a good one to use there. Temperatures look pretty close. Yeah, not bad. Another model we can look at, this is the National Severe Storms Laboratory, ARW. This is a different physics package. And these are only, I think, run at 12Z. But I've noticed over the past winter, this NISL model has been pretty accurate with convective precipitation. So I've been looking at this a lot more than some of the other models. And you can see 12 hours got that pretty good. And that's excellent considering that's not an INSEP model. So not as good modeling resources as they have in Washington, D.C., but it still held up pretty good. And yeah, the temperatures here, I worked out the temperatures according to this color scheme, and it nailed that 29 there at Oklahoma City. And then another model here, this is the RDPS. This is the Canadian, you might say the Canadian version of the WRF. It's their own model, but this is a 12-hour forecast, and it's fairly close. And I think that's pretty much it right there. One other thing I wanted to show you is on some of these model forecasts, let me see if I can find the GFS here. There was something in this model data I wanted to show you guys, and I can't remember what it was. Oh well, I'll have to save that one for another time. Anyway, that's plenty of model verification there. And one thing that you should keep in mind is when we have this kind of creep going on, where each successive model run is placing it further and further south, that's probably a good indicator to look for it even further south. So it's good to do this kind of verification, and when you have a front coming through that's very important like this, that's another tool you can use. You can become a critic of the numerical models like that. Okay, so back to our panels here. So the front is pretty much south of Dallas, and we'll look at a sounding here. We're trying to work with one sounding every day. You can see predominantly southerly winds all the way up through the column, and I can see one little plot here. Let me paint over it. One little northwest wind plot right there near the surface. So this is a very shallow cold air mass. Topping out at about 925 millibars, that's about 2,000 feet deep. So if you're on top of one of those big radio towers like at Cedar Hill, you start your climb at the bottom of the tower, it's 38 degrees. By the time you climb to the top of the tower to change the light bulb, it's almost 60 degrees. How about that? And above that, above Dallas, you can see a little bit of this warm air advection layer, this isentropic lift, giving them stratocumulus and some rain. And above that, there's our cirrus layer based at about 24,000 feet. And I'll show you the vorticity chart. Instead of doing that, I'm going to... I guess I'll pull up the Canadian vorticity chart here. This is the GDPS model. All right, so there's current conditions. So you can see kind of like a very broad ridge right there across the southern plains. And the main energy is off the coast, off Baja California down there. And you can see in between, we don't have any advection lobes moving through that area. And by an advection lobe, I would mean, let me give you an example of that. Yeah, you see these here? Another example, this. Hang on. It's off the screen there. Yeah, this here. These are pockets of, these are disturbances moving through the flow, where the flow is out of balance, and we have to use vertical motion to restore that balance. So we don't have a whole lot of that going on here between Texas and upstream. So this is the reason we're looking for some pretty quiet weather. And most of the precip north of that front, north of Dallas and Oklahoma City, is mostly just driven by overrunning as the air mass climbs over the top of that cold air mass and condenses and precipitates. And to a certain extent, as with some of the pressure falls approach from the west, we may see some lift from upslope flow as the easterly wind components at the surface start picking up a little bit. So we'll have to watch for that. So what are we looking at over the next couple days? Yeah, you can see a little bit of energy, a little bit of disturbances move through overnight. Otherwise, yeah, there's one right there. So fairly quiet, and we don't really get into the heavy dynamics until Sunday midday. This is the 18Z chart. And by 0Z, Sunday evening, 6 p.m., it's looking like this. Strongest lift is focused out in this area here. So the main trough looks like it's back here. This is all a big area of lift. Moving across the Dallas, Oklahoma City, Childress, Amarillo area. So that's when we're expecting the precipitation to really start picking up. And that'll move to the north, and then we get, looks like a kind of a double shot of energy. Here comes another one for Monday night and Tuesday. And things aren't over until this main trough moves off to the east, and that's going to be probably Thursday night. So it looks like probably a busy week in Texas over the next few days. And for tonight, I decided to start us out with the GDPS instead of the GFS for our first 240 hours. Since the performance of the GDPS has been so good, we might as well use that. Okay, so let me get this all set. All right, so you can see the cold core, cold pool off of the Los Angeles, San Diego coast right there. So kind of some unstable air right there. And you can see the warm air out ahead of it in the southern Rocky Mountain region. And that surface front kind of follows that inverted trough like this. It's very hard to pick out using just the trough, but we did our surface analysis and we know that's about where it is. Okay, let me just look at the chat real quick and see if there's any issues. Okay. Yep, Tom J, just north of El Paso, and it's warm there. So, yep, right in this area where we have the thickness ridging. That bulging of the thickness contours, that's due to a lot of warm air right in that area. And we can see that on the soundings. If I pull up the El Paso sounding, you can see we start out with a pretty warm surface temperature near 70. And pretty warm all the way up to the tropopause up at about 40,000 feet there. And we can see a kind of a cirrus layer there too, based at about 16 to 18,000 feet. And this is what we call an inverted V sounding. You might have heard of this. If we had a good source of lift, like a shortwave moving through, what would happen is we would precipitate into this dry air. We would entrain this dry air, and we would get some strong downdrafts with that. This is kind of a pattern of what we see a lot of the time in the summer in Colorado, like at Denver, these inverted V soundings. And all we need is basically the inverted V pattern. We need very steep lapse rates, kind of like what you see here. Things are actually kind of primed here for high base showers and thunderstorms here, but the main thing we're lacking, of course, is the upper level disturbances to destabilize things a little bit. Also, we probably could use a touch more low-level moisture. Probably in a situation like this, probably some of this moisture is actually what's going to be what's important here. So if we lift a parcel up from that, it's slightly capped up here. So this is the reason we would need a little bit of destabilization, kind of erode some of this, kind of build the lapse rates up through here. And that would give us some high base showers. This is probably a little bit too high, though. You can see we're based at about 500 millibars, that's about 18,000 feet. We would ideally like to see that probably a little bit lower, down near 10 or 15,000 feet. All right, so back to the maps here. Okay, let's move forward and look at our forecast for Saturday when we do the webcast tomorrow. Dynamics starting to move out of the Baja California region. Not quite there, but the isentropic lift definitely working the air mass here. And trying to figure out a way I can pull up the 850 millibar chart without killing the internet connection. Let me give that a try here. Hang on a second. I'm trying to be very thorough here, and if there's something I want to include, I would like to try to push that in there. Okay, that's going to be a 36-hour forecast. Okay, there we go. Perfect. This is the 850 millibar chart for tomorrow night. And you see that those winds there, very strong southeasterly winds, 30 to 35 knots, kind of a low-level jet, sort of. That's bringing up a lot of moisture and warm air crossing over the frontal boundary here. So this is an area of very concentrated lift of very moist air. So this area right here around Amarillo, that's very primed for precipitation. And this is moving north-northwest in response to these very strong pressure falls in the southern Rockies associated with that upper-level trough here. So everything is kind of tied together. If it wasn't for that front right here, probably wouldn't have a whole lot going on in Oklahoma and North Texas. And there's that heavy precipitation, and just north of that, freezing rain. See that freezing rain up there north of Enid and north of Wellington. Then for Sunday, heading into the forecast then, it looks like our system pulls out of the southern Rockies. And I'm not too sure exactly where that surface front is going to be. It could be here, could be up here. We would probably have to take a look at the temperature charts to kind of resolve that. But the Canadian model keeping most of the wintry precip north of Wichita into the Pratt and Dodge City area and north of Amarillo. And you can see behind it snow showers with the main cold core low coming in. And the system tracks very strongly to the northeast. So now it's coming through the Midwest region. Front kind of like that. Occluded system back to the surface low near Des Moines. And kind of a narrow band of wintry precipitation in Minneapolis and Sioux Falls. And looks kind of like liquid rain right there in Indiana. Yeah, looks like they're just not, the Canadian model is really not going for that. Keeping most of the ice just north of Chicago and north of Detroit. So skipping ahead to, let's see, Tuesday, Monday? Yeah, we're on Tuesday. System kind of fills in over the Great Lakes area right there. It kind of tracks. Tail end starts developing this squall line, so we're starting to get some very strong moist advection off the Gulf, feeding that line. So that with these disturbances working out of here that we saw in the 500 millibar chart, that's going to be a good setup for storms and rain there. And the south really needs that. For Wednesday, everything moves to the east. Starts clearing out a little bit. There's that weak front moving into Pennsylvania and Virginia. Very weak cold air advection coming in the backside here. I realize that that's just off the map right there. There we go. Let's try that. So there goes our system out into the East Coast. But things are picking up out in the Pacific Northwest. Very strong pressure gradient. Looks like probably a good chance of some wind damage, very heavy rains out there in Seattle and Portland. Again, this is going to be Wednesday. Then Thursday, there's the cold core low, the second cold core low, moving across Texas, and we get some showers with that. But the main frontal action is down out in the Gulf. So you see that right there. That's the frontal system associated with this next low coming out of the southwest. So if we have any severe weather, that's mostly going to be confined to the Mississippi, Alabama area. Again, this is on Thursday, the 19th. And for our webcast on the 20th, on Friday, things move out east. Cold air advection into the southeast U.S., and things become pretty quiet out in the central plains. A little bit of banding there of the thickness, so we have to kind of keep an eye on that there. Saturday and Sunday, pretty quiet in the central U.S. Looks like showers and strong westerly winds there in the Pacific. and we get to the end of the Canadian model. But we can see we start developing some cold air advection right there with this, looks like a little bit of an Alberta clipper maybe coming out of the Dakotas on Monday. And we'll just kind of whip through the GFS real quick. GFS is going for quite a system here. We didn't see that on the Canadian model, did we? Where did that come from? Came from the Pacific here. Came through Nevada and California on the 21st. What did the Canadian model have for that? Well, it had a system, but mostly well to the north up here. Actually, I can probably see a little bit of a front right through here. Looks like the GFS really developed that system quite a bit. And we'll just check out real quick what the GFS is doing with that. Well, another mystery to see what happens for next weekend. So GFS going for funnel system here, moving into Texas. What's important, though, is the thickness banding that's well to the south there. We have to kind of keep that in mind. So we're probably looking at something like that with an occlusion coming back into Oklahoma and dry slot across Texas like that. So yeah, this looks to be, if that pans out, that might give the southeast a chance of severe weather there. Certainly looks like shear profiles will be adequate for that. We're talking about the 22nd and 23rd here. But remember, the Canadian model didn't forecast any of this. Big Great Lakes system there, 980 millibar low over Michigan. There we go. And lots of cold air advection working in back behind it. And then pretty quiet for the rest of the period. Okay, that was quite a lot to cover there. Hopefully y'all were able to follow that. If things get too dry or boring, just let me know. I don't want to make this too an ordeal to get through. But, you know, I am trying to cover as much as I can, as much of the U.S., all the time frames, and I'm trying to do that without making things too dry. Okay, guys, I think that's about all I got here. I appreciate you watching, and hope you'll be back with us tomorrow at 8 o'clock, and we'll see you then.